Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Amir Adha bin Mahzan, and my material number is 192555. So I'm from the Bachelor of Agricultural and Biosystem Engineering with honors. So today I will present about my final year project for the FIP day, which is application of the SWOT model for water balance simulation in the 16 UPM watersheds. So let's move for the introduction. First is the water balance concept. So water balance is the motion of water from atmosphere to the earth, taking into account precipitation, evapotranspiration, groundwater discharge, lateral flow, and runoff, as we see in the figure. So water balance can be used to determine areas' specific climate features, typical landscape, and opportunities for human land use. So it also uh, can help to manage the water supply and predict where there may be water shortage in this certain area. So the problem is the environmental change, such as El Nino, because it will give the effect to the amount of precipitation. As we see, Malaysia facing strongest El Nino event in 1997 to 1998, that dropping the amount of rainfall up to 50%. So the rainfall is very important for the water balance because it will maintain the water balance in the ecosystem. So if the environmental change happens, such as El Nino, it will reduce the precipitation and it will give a problem to the water balance in the region. So from the problem, the main objective of my project is to evaluate the parameters of water balance based on rainfall changes due to El Nino phenomena in the 16 UPM using SWOT model. So the specific objective is to analyze hydrologic response unit using combination of geospatial data. Second one is to simulate hydrological model of the 16 watershed based on different rainfall condition. And the last one is to generate water balance component due to environmental changes. So the limitation for this project is the calibration and validation process of the model cannot be evacuated due to the lack of observed stream flow data from the study area. So as we know, Lanamblas is an unwashed area with no station available to collect the stream flow data. So for the method of this project, this is the general overview of the project, which is starting from the data collection of geospatial data and meteorological data. So after that, the geospatial data will be overlaid to create a hydrologic response unit, which is HRU, as we see in the flowchart. And then the meteorological data will be put into the weather generator data. And lastly, the SWOT model can be run, and the assessment of water balance equation component at the 16 UPM can be known. So this is the first step of using the input data, which is the watershed delineation process. It consists of 5 major steps, which is DAM setup, stream definition, outlet and inlet definition, watershed outlet selection, calculation of sub-basin parameters. So Alus Parser retrieved from NASA Earth data with a size of 12.5 meter was type of DEM that has been used in this project. So the next step is on the hydraulic response unit analysis. So the hydraulic response unit analysis need loading of land use, soil and slope characterization for the watershed. So as we see in the figures, in the colorful figures, that's the land use data that has been used. It showed that Anambas has 6 classes of land use, which is water, forest mix, pasture, agricultural land generic, range grasses, and the urban area. And the next figure is the soil map that has been extracted from the Food and Agricultural Organization (FAO) with a 30 meter spatial resolution. So based on the map, it it's shown that the type of soil in the ladang 16 is sandy clay loam. Next one is the weather generated data, where we put the meteorological data into the AXO interface for the SWOT to run. After the SWOT has run, there will be the assessment of water balance equation parameter that has been simulated by the model. So the parameter that has been simulated by the model is R precipitation, evapotranspiration, surface runoff, groundwater discharge, and lateral flow. So the water balance equation parameter that's been simulated by the model will be compared with the minimum and maximum amount of rainfall data to find out if the components are affected by the change of rainfall event. So for the result, this is the result of watershed delineation process. As you see at the figures, with a purple line, it is a watershed area from the 16 catchment. So as we see in the right figure, there were 27 sub-basins been delineated from the Ladang 16 watershed. Okay, for the shallow analysis, okay, 4 major classes are also identified in the watershed. So from the HRU analysis, it showed that the agricultural engineering has the biggest area covered with 25.4 hectare in the watershed, and the forest mix has the least cover with 0.5 hectare. So this is the detail of recorded HRU after an overlay process in the soil interface. Yes. So it's come the water balance component that's simulated by the model. So water balance. So the water balance component are precipitation, potential evapotranspiration, actual evapotranspiration, surface runoff, soil water, lateral flow, and the contribution of groundwater to stream flow. So for more understanding, the figure show the diagram of the water balance cycle and the watershed. So contribution of groundwater to stream, which is GWQ, has contributed a large amount of water loss, which is the 7%. So GWQ is the water from the shallow aquifer that return to the ridge during the time step, and it varies badly among stream. So it means that the groundwater has been discharged from the system and going to the stream. So the high amount of groundwater discharge might be due to the hydraulic head of the groundwater system. It's higher compared to the head of the stream, which contribute to higher amount of groundwater discharge from the system to stream. So there's been a study related to groundwater at the 16 ppm from Ibrahim et al. 2019. And they reported that there is the presence of groundwater 10 meters from the surface, and the groundwater flow direction toward the stream, which means there is a high chances of groundwater discharge from the system. So, result for yearly total precipitation were used as shown in bar chart to know the minimum and maximum value of precipitation during 90 years of simulated period. Okay, from the result, it showed that the study area has received a maximum precipitation on 2006, which is 2,917.4 millimeters, while the minimum precipitation is in 2019, which is 1,182.76 millimeter, which there's different about 25% of the total precipitation. So according to annual report for 2019 from Malaysian Meteorological Department, it was reported that Malaysia has experienced a weak phase of El Nino in 2019. So it proved that El Nino phenomena has occurred in 2019, that reducing the amount of precipitation in the Peninsula Malaysia. So from the water balance component that had been simulated by the model for both 2006 and 2006 and 2019 are shown in the bar chart. So results show that the amount of surface runoff is higher on 2006 compared to 2019, which means there is more water from precipitation that arrived on the ground was directly infiltrate into the aquifer on 2019. Another possible process was it consumed was the precipitation water has been consumed by the crop to keep alive. So there was low amount of uh, severe runoff, which is surq due to minimum volume of precipitation. So the amount of ET is higher on 2019 compared to 2006, although it has minimum amount of precipitation. Because of the increase in temperature due to El Nino phenomena on 2019 that have led to increase the amount of evapotranspiration. But if the El Nino occurred in a long time, the amount of ET might will be decreased since El Nino will reduce precipitation and leads to lower terrestrial moisture content. So there is less water in the soil available to evaporate. So for in fact the environment to sustain that, so this simulation of SWOT model will be able to improve water management on study area. They also have to manage water supply on study region. Then lastly, we're able to predict future hydrological cycle for prevention of natural disasters such as flooding event and drought season. So for the conclusion, and simulation of water balance component have been successfully conducted using SWOT model for small watershed and non-anomalous UPM. So SWOT model has been able to analyze hydrological response unit using combination of geospatial data. Second one is SWOT model has been able to simulate hydrological model of the anomalous watershed based on different rainfall conditions. Since the SWOT model have been able to observe the water balance component in the ladang anomalous area. So the last is the maximum and minimum total precipitation from year 2006 and 2009 respectively had proof that it has effect the water balance component during the El Nino phenomena. So for the recommendation, this model cannot undergo calibration and validation process due to the lack of SimFlow data. So I have recommend for further studies to extend the area of study into a watershed that contains Gulf station. So hence the validation, calibration and validation process can be done. So that's all from us. That's all from me. Thank you very much.